when we add or subtract numbers, our imaginary numbers, it's just like adding and subtracting polynomials. First thing I know is I'm subtracting here, so I'm going to rewrite that second parenthesis. So I'm going to say 4 minus 6i. I'm going to distribute my negative sign inside. So I'll say plus negative 3 plus 7i. Now I can combine my real parts. So I've got 4 and negative 3. 4 plus negative 3, well, that's 1. And then I'll combine my imaginary parts. So I'll say negative 6i plus 7i. Well, that's just 1i, so plus I. So when you add or subtract complex numbers, we add or subtract the real parts, and we add or subtract the complex part. Now let's take a look at an application here. It says in AC circuitry, the voltage E, the current I, and the impedance Z are related by this formula, E equals I times Z. So find the voltage. In other words, I want to find the E in a circuit with a current, which is I. That's kind of confusing, but capital I, and an impedance with Z. So what happens here, to find the voltage, which is E, we're going to multiply I times Z. So in other words, I'm going to take I, which is 1 plus 4i. I'm going to multiply that by Z, which is 3 minus 6i. Then, let's multiply these together. It's like multiplying binomials. Distribute. 1 times 3 is 3. 1 times negative 6i is negative 6i. 4i times 3 is positive 12i. 4i times negative 6 is negative 24i squared. I'm going to rewrite that I. It looks kind of sick. So minus or plus 12i, and then minus 24i squared. Now I can combine my i's. So I'm going to take negative 6i plus 12i. I'm going to add those together. So I'll say 3 plus 6i. Now remember, I squared is negative 1. So I have negative 24 times negative 1, or just 24. So I got 3 plus 6i plus 24. Combine your like terms. 3 and 24, that's 27. So you get 27 plus 6i. And there is your solution. A complex conjugate is two complex numbers where the imaginaries are opposite. So if I have an imaginary number, a plus bi, the conjugate then is a minus bi. We keep the real part the same, but the imaginary part we're going to do the opposite.